Welcome to my session. The DSC Pull Server is dead, but long live the DSC Pull Server. I don't know if you guys noticed, but Microsoft put up a blog post about the future of the DSC Pull Server, stating that they had one leg of innovation left, being SQL support. And there will be like end of innovation on the on-prem DSC Pull Server, right? And all the other effort would go into Azure Automation DSC. But I think with that SQL support, we kind of touched upon a new era for this inbox DSC Pull Server, which is everything this session is about. So let's dive in. So, oh, by the way, my name is Ben Gelens. I'm a consultant working for a Dutch consulting company called Inspark, Cloud and Data Center Management MVP. And if you want to reach out to me, you can find me in a lot of places. My main handle is Gelens. So. And let's have a quick look at the agenda. I'm going to talk a couple of minutes about the status quo. So what's the current state of the DSC Pull Server? I'm going to talk about what RS4 is bringing to the table, meaning the SQL support and so on. And I wrote some proof of concept code, which I want to share with you guys, and hopefully spark some excitement about contributing to the inbox DSC Pull Server by expanding additional services on top of it. So, status quo. Currently, we have MDB support, which was brought in with WMF4, with the original Pull Server, which is a 32-bit accessible MDB database, so basically an access database. Can grow in size until 2 gigs, and if it reaches those 2 gigs, you need to purge out some records to make it usable again to send reports to, right? The newer one is EDB support, so that's actually available since WMF5, PowerShell 5 version, where we have ESENT driver, and we don't have the limitation of the 2 gigabytes. Actually, it's a NoSQL database. But it's a little bit difficult to access that database once the Pull Server is up, because the Pull Server will lock it, and you cannot get into the database anymore to manipulate anything. So there's a couple of community projects. We have the MDB linked table, which is something that can get out of the door as soon as you guys see the SQL support that's native to the new DSC Pull Server. But it kind of alleviated that issue of the 2 gigabytes and availability issue. Of the Pull Server. Then we got some community projects, Talk and Drake, where Talk is like a reimagination of the DSC Pull Server. I have to say I have not touched it myself yet, mainly because I have customers that say, hey, we want to make use of Microsoft technology in the sense that we need to pick up the phone when we have infrastructure problems. And we cannot do that with Talk or with Drake, right? And Drake is re-implementation in Node.js, microservices architecture. It's difficult to pronounce, but it's fun to see the DSC Pull implementation being implemented in kind of different kind of projects. And of course, we got Azure Automation DSC, which is the most scalable and well, best available DSC Pull Server out there currently. But I have a couple of customers that just don't want to go to the cloud for some reason or another. Maybe they have network segregation issues where they cannot reach out to Azure Automation in any way. But that's kind of the status quo. And with RS4 from build 17093, if you're in the sec release, so that's the what's the sec again? Well, anyways, that's the 1803 build or 1709 build of Windows Server. And it will not be backported to earlier OSs, at least that's what they told me. But we get native SQL support from this moment on. So Server vNext, Server 2019, and the sec releases will bring that forward. And it will be supported for the entire lifecycle of that DSC service Windows feature we all know about. So it will bring scalability, it will bring availability. We are rid of that 2 gigabytes limits or the unsupported linked table thing with the MDB. We don't have to deal with ESENT anymore, which is great because we don't have to shut down our Pull Server anymore if you want to go into that database. And because we have that SQL backend, we can easily go in with some SQL statements and manipulate data or get data and do all kind of stuff. And for the first time ever, it's going to be really easy to change the configuration names of your LCMs on the server side. It was possible already since the introduction of configuration names, since WMF5. With Azure Automation DSC, it was really obvious to do it, but with the on-prem pool service, it was really hard to do it. And with that, I'm going to set up my first demo. So what we will do is we will instantiate a pool server. Actually, I'm not going to do it HA because I got a skinny laptop here. But this is possible. We can put a load balancer in front of it. The SQL implementation will be HA or will be maybe, I'm not sure if it's supported, but could be Azure SQL or something. And our LCMs, they will call in through that load balancer and reach one of those pool servers. And we have an admin box that's capable of dealing with some SQL statements. And with that, I want to introduce that SQL support through a demo. So I have this Hyper-V environment containing 3 hosts. It's probably not seeable in the back, but I'm mainly dealing with this CO01. And on this CO01, which I'm remoted into right now, I already have that DSC service installed. Because that DSC service installation takes a while to process, because it's also installing IIS and all kind of subcomponents, and I wouldn't want to bore you with that. As well on this system, I already installed the XP's desired state configuration resource module, version 8100, which is the latest release, which brings the web config configuration you have to set for SQL support. And we can see that by looking at the XDSC web service resource, we can see it brings SQL connection string and SQL provider settable parameters, right? So what they did not check with this resource is some localization issues I have with it. So I need to implement some workarounds. But hopefully when you guys get back to work and want to try out this kind of stuff, that PR that's outstanding that fixes this issue is already merged and published. But for now, I just need to create some localization folders to make sure that this resource actually works on my system. And I have this basic configuration pool server SQL, it's called, and it just imports that XP's desired state configuration resource module. And it has a resource declaration of XDSC web service. And as you can see here in the bottom, we're going to make use of that SQL provider. And we have a SQL connection string in there, making use of SQL native client tooling. And it's going to connect to C-host 02, which is another VM on my Hyper-V implementation. Everything else is still the same. I'm not dealing with any SSL encryption stuff here because I just wouldn't want to burden myself with a lot of additional demo aches. So we're having a pool server that's not really secure and you shouldn't implement, but it's okay for demo purposes, right? So let's just have that into memory so we can call it and compile a MOV file. There we have our MOV file. And just before I do that, let's have a quick look at SQL Management Studio, which is connected to that SQL server. And as you can see, currently there's no database in there besides the system databases. So let's effectuate that configuration. And this machine will now be converted into a pool server, but configured to make use of a SQL backend. And we can see that by parsing out that web.config that's being created for this pool server, and we can see that connection string being embedded there. So to instantiate the database creation event, actually a first node or report has to be sent to the pool server. That will trigger the database creation. And to do that, I have this standard configuration dealing with the meta configuration of the LCM on this machine as well. So we're going to set this machine into pool mode and just target it to the local computer on port 8080. Everything as you already know about, right? At least, who here is using DSC? Okay, so most of you, thanks. So let's get that meta config and apply it. So now this local machine is onboarded into this local pool server, but anyways, it serves the point, right? We now have this SQL demo database here. And it has a couple of tables, and if it's not visible in the back, I just call them out. So we have a devices table, which is the V1 implementation. So you have any records into this devices table. Something is going wrong with your LCM onboarding because they onboard using the V1 protocol. So you wouldn't want to have any rows in there anyways. The registration data table is where all the V2-based LCMs will put their registration in. And this is where we can see those agents IDs. Let's do a select statement there. Agent IDs and configuration names, for example. So here we see that CO01 that's onboarded right now, it has no configuration names, and this is his agent ID. So really nice. We also have status report table, which basically just has all the reporting data every LCM is sending back to the pool server. So because now we have SQL support, it's also really easy to create some SQL statements, manipulate it to your own requirements, and say, for example, I only need data, but in this case not for 1 node, but for 20 nodes during this time period, for example. And that would be, that's a major improve, if you ask me, through the current implementation through REST. But we will see that in the demo in a little bit. So how would we go now and in normal ways talk to the pool server through the REST API and get node data out of it? So you would use invoke REST method, and we have this basic URI construct, chost mshome.net on port 8080, targeting that DSC Pull Server SVC service. And we need to provide some header information stating that, hey, we're talking to you based on protocol version 2. And because I never opened Internet Explorer on this machine, I'm going to use basic parsing. So if we do this, we can see all the routes that are available on the pool server. So this is like the basic test to see if your pool server is operational, right? Now, if we want to get a node object out of that REST API, what we need to do is we need to provide the agent ID of the LCM in our query to send it to the nodes route, and then we have the agent ID embedded there. So we have that in this variable right now, and let's call that out. So as you can see, I got back a node object from that REST service. So that's the same one as you saw using that SQL select statement. And you can see the configuration name was not assigned. So how would you do that through the REST API? You want to do server-side assignment of the configuration name. Is actually, I thought it was not possible, but by constructing this demo and seeing that it should be possible through the API document I'm talking about here. So when my demo files are up, you can have a look at the documentation here. It would actually be possible to do it, and it is possible by basically doing a re-registration of the node, so overriding the record. And to do that, we need to do a put method, and we specify an additional authorization header, putting in that registration key you used initially for onboarding. So if we put that into memory, and the node object we originally got from that pool server, we strip it a little bit for information that the pool server does not process. And now, for example, we're going to specify the configuration name, going to be psconfu, and we need to put in a registration message type, and that's going to be configuration repository. There's like 3 of them. We have a module repository as well, and I believe reporting repository or something like that. Anyways, this just needs to be in there, and it's all documented. And if we query the machine now, we can see from the pool server we get that assigned psconfu configuration name. But how would you fan that out, right? You need the agent ID to talk to that pool server in the first place. So if you need to set configuration names for like 20 nodes, first you need to get those 20 agent IDs. Where do you get those 20 agent IDs? That's kind of a tough job to handle. You probably have some kind of offloaded database, just doing the cross relationship there with a node name and a configuration or an agent ID. So that's pretty difficult. So I'm just resetting the configuration name to null again because I don't want to hit myself in the head in a later demo. But getting reports is basically the same as getting the node object, but we append an additional reports route to that URI. So I already got a report from it, and it's a bit messed up in this zoomed in, but anyways, you can see I got report data back from that pool server. But again, I needed to specify that agent ID to get it. So it's difficult to get more like anonymous access to that REST API and say, I need the last report for the 20 nodes or something like that. So multi-nodes is as far as I know, it's not implemented. So what you can do now with that SQL support is write some basic SQL wrapper functions and just call out to that SQL backend. So what I did here is just I loaded that connection string into memory and put it in my PS default parameter values for every function that has DSC Pull Server in the noun. And those functions don't yet exist because they are stated below. But we got a function for get DSC Pull Server registration, just getting the data out of that registration data table. It takes that connection string, as you can see here. And in this case, it takes a node name, which is probably a bit friendlier as the agent ID, right? And we just set up a basic SQL connection, doing some, well, if the name has a wildcard, doing some SQL kind of replacement here, because the wildcard in SQL is a percentage and not asterisk. I'm not really big in SQL, so there's a lot of people probably here knowing better ways to do it. But anyways, we construct kind of a SQL query based on if there's a name or not, and then just execute that statement on the SQL server and parse out the results and normalize that a bit for some better readability. So let's just do that real quick, load it into memory, and see it working. So this query just goes out to the SQL host directly. So as you can see, it's really fast because it's SQL, of course. So, and just to show you that wildcard support, you can see that the SQL statement here has the where node name like addition to it. So now I want to get to that SQL server and get some report data out of there. So same thing, set up a connection string, a little bit of different select statement here, even do some datetime additions to that query, and again filter out the data and normalize it a little bit. So just to see how easy it is to talk to that server without specifying a node name, we just get anything back. You can see the latest report sent from this node was an onboarding event. So it's a local configuration manager operation, and that was handled successfully. So, and just to show you that we could now add also a start time, you can see here from the select statement we have a start time definition in our query, right? So how would we set a configuration name through SQL? Well, first I'm going to define a configuration here. It's called my super server, and it just creates a file, a super file, in C Windows temp, and it just states psconfig rocks, right? Because, well, yeah, that's a fact. So let's just load it into memory, so we can call it out and compile it, but put it directly inside of the DSC Pull Server configuration directory. And we need to generate a checksum with that, or else the LCM will not find that it has a new configuration available, right? So if we currently look in SQL and we see the configuration name is not set, so we need a way to set it. And to do that, I've written this little function, set DSC Pull Server node configuration. And again, it takes a name for the node, a configuration name for the configuration we want to assign, and a connection string. And in this case, we're going to do an update into the registration data table for that specific node name. And we put in our configuration name in a JSON-like format, because that is what is required. We executed a non-query because we're not getting any results back. So it's becoming really easy. So now we just pipe in the node object we get from the first function and pipe it into set. And now if we, if we query that again, we now see that configuration name super server was set on the server side, right? In the SQL database. Still, the local LCM doesn't have any configuration name assigned. So the assignment was will be 100% server side, just like you are used to with Azure Automation. So let's see it in action, and we can see that it indeed pulled down that configuration. And if we look at the content of that file, psconfig rocks, that's actually in there. So, and we can see the configuration has been set, and also that it was an initial pull. And just to show you that there's currently no configuration name locally in the LCM configuration, you can see that here. With that, I'm going back to the slides real quick to introduce the second part of this session, which will be extending upon what you just saw. So what are the next things we could do with this? Now we have SQL support. We can easily scale out our DSC Pull Server farms, right? Instead of 1 node, we could now have 2, or maybe 20, maybe 40. So let's containerize that pull server so we can have a predefined image and have something available that runs on my machine, runs on your machine, runs in Google Cloud, runs in Amazon, runs in Azure, runs anywhere, right? With a container image, that's going to be a really easy thing to do. And apart from that, we're going to introduce, in this session at least, a couple of additional functions like a REST API to get admin reports out of that SQL database without talking to that SQL database directly, because you don't want to expose your SQL server on the front end. You want to put some RESTful API in front of that to make it a little bit more secure, right? Configuration assignment, admin module management, stuff like that. You can think about this a little bit, what's possible now through that additional SQL support. So introducing the next demo, I have a Docker swarm on my machine, which is a cluster of 2 Docker nodes. And in my case, it's just 1 because of the limited capacity, but the swarm makes it really easy to have 1 or multiple nodes running as a cluster. And I have this highly available folder in there that's provided by Storage Spaces Director or something similar to that. So, well, the SQL support didn't address the issue that configuration MOV files and modules and registration keys still need to be persisted on disk somewhere, right? So you still have that issue to deal with. And with Docker, it's really easy because you can just have a highly available file or folder somewhere and just have multiple containers read from that same space. So we have that. Then we have the HA-SQL implementation. We put in some pull server containers. We put in front a load balancer of that Docker swarm. So if you hit that load balancer, you will be pointed to one of the Docker swarm nodes, and Docker swarm knows, okay, it needs to reach a container for a pull server, and it just routes your request to one of the containers. And then we have this admin container, which will have another but more secure endpoint, because it's for administrative purposes. And the admin box will talk to that endpoint. And with that, I'm going to the second part of the demo. So on the same box, it's also a Docker swarm machine. I'm stopping and removing the current pull server website just to make sure that you can see there's no smoke and mirrors here. If I run Docker version, you can see I'm running a build from the master Docker project, which is just a zip file I downloaded from a repository. And if I look at the info, you can see right here that it's Windows, and we have a manager and a node of 1. So this is just a 1-node cluster, right? And currently there are a couple of images already pre-downloaded, because downloading a Windows image, well, it kind of tends to take half an hour or something like that. So I pre-downloaded a Windows Server Core Insider image that works on this build of Windows Server. And to show you this version table, the current version of this Windows box is 17623. So this is a preview build of Windows Server vNext, the 2019 Insider build. So what I'm going to do now is just pre-create some directories, and I'm going to need those directory structure for my Docker build in a little bit. Bear with me. I'm just going to copy in a lot of files and start off a Docker build. It will take a while, so I will talk about what's happening during the build. And let's instantiate that build. So what I'm doing here is I'm calling into a subcommand of Docker, it's the build command, and I target it to this folder which is in my path, and it's called Pull Server Container. And the end result will be that it will look for this Docker file. And from that Docker file, it will create a container image. Oops, that's this one. And it will tag that with a repository name. In this case, it's just my handle. And we'll give the image the pull server name with the latest tag. Okay? So while it handles that Docker file, we can see that it's creating a new image which is based upon that Windows Server core image that Microsoft pre-built for us. And I'm using this specific tag because if you now download the latest one, it's not the one that works on this machine. So I'm going to be really explicit with this one. I'm going to put in some metadata stating that anybody who is using this container image, well, the resulting container image, can reach out to me if they have any problems with it. And I'm just going to copy in a couple of folders and files. So the modules file, this will basically just copy in the XP as desired configuration resource module. It's going to copy in a script and a SQL native client, MSI package, and a monitoring script. What you do when you instantiate a container, you need to provide it with some sort of heartbeat, right? It needs to be kept alive. So if you do docker run -it, that means you attach a terminal session to it. That's kind of your keeping it alive thing. But if you want to host services that run on their own, then the service you kick off needs to be running until something bad happens, and then Docker is informed that, hey, the runtime I'm expecting inside of this container has died. I need to create a new container from it. So during the build, PowerShell is called, and it's calling this Docker PS1 script that actually does all the automation needed to create the image. And after that, it will remove all files we don't need anymore because we like to keep our container images lean. We state some additional information that inside this container, there's a service being exposed on port 8080. So this is just another metadata thing. And finally, we state that when you run a container based upon this image, it will run powershell.exe and it will invoke this dockermon.ps1 script. So really quick, looking at the installation script, we can see that the DSC service was installed, that SQL native client MSI was installed. All those workarounds I needed and just show you were implemented as well. We're actually making use of invoke DSC resource within the build process and providing it the method set to instantiate a pull server inside of this container image. But in this case, I'm providing a connection string which is easily searchable and replaceable for us. So #, connection string #, I can easily do a regex on that and just replace it out with anything I'm going to inject later. And once that's done, I'm going to remove the default website because we're not offering a default website in this container. And we're stopping the pull server because once we instantiate a container based on this image, we're going to inject connection string information that needs to be inside of the web.config, and we want the pull server started with the configuration it needs right from the start. We don't want to cycle that service anymore. And the build is finished, but I'm just wanted to show you a little bit the dockermon PS1 script that's being invoked every time you start a container based on this image. It just gets the web.config file, and it searches the environment variables for a connection string value there. If it's not there, it will write an error with a stop action, because if we don't have any connection string in our environment variables, there's nothing for this container to do. But if it does find it, it can go on. It will replace that connection string inside of the web.config, and it will also replace any path that is C program files Windows PowerShell DSC service with C Pull Server. This is just so that we can target multiple containers to the same directory later on. It will override that web config and it will start the pull service, and then we have this monitoring function, which is a really basic thing, just querying itself locally on the local host, and as long as we can get a response from that endpoint, we self-invoke that function again and again until something bad happens, and then we terminate the script, and that means the container just died. So getting back to working with that container images, actually, as you can see now, I have this container image created 2 minutes ago. And what I'm going to do now is create a directory locally inside of this container host. Imagine this is a highly available directory. And I'm going to copy in everything I already created for that pull server that was on this box in there. So if we run a dir, you can see we have the configuration directory, modules directory, and registration key. So this folder will be exposed to every container running on this box, and it will consume this information, right? So let's just run a container based on that image we just created. And as you can see from this -e here, we're passing in environment variables to this runtime, stating that the connection string should be, well, the connection string to my SQL server. It's running on port 8081, if I press enter. But on the inside of the container, we have a port translation to 8080. When the container dies, we remove it, and we run in like an unattended or daemon mode kind of thing with -d. So we just created a container, and you can see here we actually have a running container. And if we inspect that, all kind of information is available to us, mainly showing us that in the container runtime port 8080 is bound to the host on 8081, and the metadata and all kind of stuff. So Docker inspect is your friend if you want to know what's going on in an actively running container, right? So let's see if we can query that container and see if we can get values back. And as you can see, we get all those routes again. So can we get the node object back from it again? Yeah, we can get the node object from it again. Now if you look in, where is it? Activity monitor, we can actually see, if it's refreshing, that we have the SQL demo 01 database being called by a node named 5c something something. And when we do docker ps, we can actually see that that container runtime that's been spun up is 5c00. So it's the matching hostname, right? Just to show there's no smokes and mirrors here. So what we can do now is we can join our LCM through that container with this Pull Server implementation and have that working. So let's do that real quick. And now it's onboarding through that container, and of course we have the same database still as previously, so it will just override that record that was available for it. And what I'm going to do now is, please note, I'm still on the container host, I'm not inside of the container. I'm going to update my super server configuration by stating that not only psconfig rocks, but DSC as well, right? And Docker, of course. So let's compile that, but put it into a C Pull Server configuration directory, the directory that is shared out with all those container runtimes. Let's override that checksum and see if we can pull that down. And we converged. So through that container runtime, we actually were able to contact that Pull Server implementation. So how would we scale this out? Well, we instantiate a new container, but port 8081 is already blocked because we already have a container running on port 8081. So we need to specify it to run on another port, 8082. So what I'm going to do is I'm going to have one half of my servers talk to 8081, and the other half of my servers talk to 8082. That's not kind of the load balancing you want, probably. So what I'm going to do is introduce you to, well, for the guys who already know Docker, is no introduction at all, but going to introduce you to something that's called a service within the Docker Swarm implementation. And a service is a higher level object that basically manages multiple containers under a single namespace. And it knows that all those containers belong to a single service. That's hence the name service. And it handles basic load balancing for you and can do all kind of stuff like define the minimal amount of replicas that should be available from the get-go, define where a folder binding, in this case, should exist, and the environment variable connection string for all those containers underneath that service should contain. So if we run this, and this is the part of the demo that broke down a couple of times in my experimentation, don't be alarmed by the red text. This is just red text stating that I cannot reach the internet and find this image. So there's potential for, if you have multiple nodes, that they have different images. So don't be alarmed there. If we run docker service ls, we can see we have instantiated that docker service. It now has 2 replicas running of that image, and it's exposed on port 8080. So both of these container images are reachable over port 8080, targeting any of the nodes within this Docker swarm. And Docker provides you with JSON as return format, so you can easily investigate everything you get back from Docker in specs. And you can see here again, it's on the ingress mode, and it exposes port 8080 on the outside to 8080 on the inside. So just to show you, we have 2 running containers, so 55 seconds ago. So what we do now is because this is not supported currently, we cannot target a service on the local host. We need to go out of it, just to show you that we can reach any one of those containers. And this is really small, of course, but you can see the response here from the REST API on one of these container images that just returned the response I wanted. So highly available through a Docker Swarm and through a service implementation. It's really cool if you ask me. Thank you. But it doesn't end there, right? So if we need more capacity, we just scale it. So it takes a couple of seconds, and we got 3 containers. If we don't need it anymore, we can easily scale it in by saying, we need a scale of just 1. So right now, we have 3 of 3 container images up. You don't have to re-specify that environment variables anymore. The path doesn't need to be specified anymore. That's all captured inside of that service, higher level abstraction, right? You just say, okay, scale out. We want more capacity. Or scale in, because this is just for development. We don't need 3 running container images consuming cycles for nothing. So when we look now, we just have 1 left. But it's still accessible through the remote machine. So let's see if we can still query it. Yeah. So although we only have 1 of those running containers left, we are still able to reach out to the pool service and get the response we want. So adding a new node through that service is also possible. I have additional Hyper-V VM, just doing a meta configuration here, but stating it should target one of the Docker Swarm nodes on port 8080. Imagine this to be a load-balanced address with a normalized A record stating a DSC Pull Server production or something that just reaches to, to a load balancer that fans out to any one of those Docker Swarm machines. Let's just create that meta config real quick, set up a sim session to that LCM machine, and onboard it, and as you can see, it's coming through right now. We can even update its configuration. So this is all happening through that Docker service, right? And we have that configuration available. So, pretty cool. And if we ask SQL now about which nodes do I have inside of my database, we can see we got 2. We have the C host 01 and the LCM client available. So there's still the same SQL database. So reusing that database is becoming really easy as well. And we can also get more reporting data out of it real quick. So as you saw, this was snappy, right? This was a SQL statement, and there you have it. So really cool. And I don't know how I'm doing on time. Doing good? Okay. I like to extend this a little bit by introducing that admin container I talked a little bit about in the slides. So I have this additional demo, and I hoped I had time enough to show this. I will create a new container image hosting Polaris endpoint. Who here knows what Polaris is? Just a couple of hands. So Polaris is like a web framework that makes it really easy for you to instantiate REST endpoints in PowerShell, right? You just say, okay, I want a new get method, I want a new put method, new post method, and once somebody hits that REST endpoint, it should execute this script block. So this is really powerful, and it turns out to be really easy to use that framework to extend all kind of administrative tasks by creating them into a REST endpoint. So I'm going, again, copying in a lot of files, just so I can kick off that Docker build. And let's do that. So in this case, when we look at the Docker file, again, we're targeting that same Windows Server Core starting image. we're copying in the Polaris module. I pre-compiled the Polaris module, so I had it available. I have this admin service PS1 file in there, and I have a DSC Pull Server admin PSM1 file, which basically is just the 3 functions I showed in the first demo that are able to talk to the SQL backend. Okay? And if we look at the admin service, so this is the Polaris implementation. Again, it goes and looks inside of the environment variables for a connection string, and if it doesn't find any, it will throw a terminating error because then the container wouldn't be, well, it wouldn't have anything to do. It imports the Polaris module, and it will import that PSM1 file containing the SQL functions. And then you can see I defined a Polaris get route with a path DSC reports. So if you hit this container /DSC reports, this script block will be executed. And because currently there's no sharing of state between those script blocks, just the way Polaris is implemented using multiple run spaces, you need to be a little bit verbose in what you handle inside of that script block. So for every script block in here, I need to import that module again, for example. And you can see here I have the request object. That's something that's made available through me. And in this case, I just handled the query. So a URI with a query string, so that's the question mark and something after it. I'm parsing that out and passing the values to get DSC Pull Server report in this case. And I will JSONify the result and send it back to the requester. So also for DSC nodes, I have a get route defined, a put route for DSC nodes to make it available for you to specify the configuration name. And a DSC configuration route that goes inside of that C Pull Server directory, do a listing of every configuration that's in there, and also return the information that's inside of those MOV files for you, just to give you some ideas what you could easily do here. Then it will start Polaris on port 8080, and as we stated in the Docker file, we're exposing port 8080, so this is just hard-coded. And here we have the lifeline again. So while this loop is running, that container would be active, and once the loop is terminated, the container actually shuts down, and the Docker service knows, hey, my container is down, I should recreate a new one because something bad happened. But of course we want uptime, so it will reinstantiate a new container. Demo 3, sorry. So that container image is already built, was really lean because it's just running PowerShell. And there's not much to do. So we can see we now have that Pull Server admin image available. It's created 2 minutes ago. And I am able to create a service. In this case, I'm going to bind port 8081 because in the entire swarm, port 8080 is already claimed by my Pull Server implementation. And I'm going to bind that same volume, well, that same directory also to this container, and specify that environment variable for the connection string. So now, if everything went correct, we have 2 services available, and we can see we have the Pull Server and the admin server, of which still none of the containers were active, but now we have an active running container hosting that admin endpoint. And as you can see, I have 2 containers running. So let's exit this session because, again, I cannot target localhost with a service. And just use invoke REST method targeting the Docker swarm on port 8081 and ask for DSC node. And there you have a RESTful sendback of every DSC node that's available inside of that SQL backend, but provided to you through a REST endpoint you have control of. And can lock down and make secure, and it's really quick, of course. Here I'm going to do a put method. So for the node name with, or for the DSC node with node name chost01, I'm going to override the configuration name with this everything is awesome configuration. And as you can see, right now it has my super server. So if I'm calling that and query that node again, so right now I'm just doing a query string for specifically this node, you can see that the configuration name was updated to everything is awesome. So, and it was really quick, right? So it's just all SQL statements in the backend. So this just, it still amazes me personally. So a directory listing of everything that's in that configuration directory. So here you can see the my super server file was in there, and this is its content. So you can, as an admin, easily see what's in there. And well, you can do like a ton of other things. So I played with a lot of ideas, but I just had this much time to prepare this session. But what else could we do? We could implement authentication, adding and getting modules, adding configuration. Well, basically replicate Azure Automation DSC, right? And have this available as a Kubernetes implementation or something that just instantiate that kind of environment in a couple of seconds for you. Layer in admin dashboards, a universal dashboard maybe, something like that. Maybe extending the LCM download manager to handle certificate assignments through another endpoint or something like that. You tell me, a lot of things are possible. So, return to the slides. Summary. With RS4+, we have a supported extendable and scalable DSC Pull service. And I think I just showed you that. Containerizing the pull server unlocks many new scenarios, and it's an easy format, right? If I now push this Docker image in Docker Hub in my repository, it's available to all of you. And you can just do Docker pull or Docker run, give my repository name and my image name, you pull it down, and you have an instant pull server available to you. It takes a couple of minutes to download because it's a Windows Server container, but it's instant. Polaris and any other web framework written in PowerShell, so also think about Universal Dashboard and Flancy and all the others. That really makes it easy as well to have an implementation for you to provide REST endpoints, but just written in PowerShell. It makes it really easy to extend upon. So, if I still have time, I have time for questions. Yes?
Is there a way that you actually can synchronize the configuration names that you see locally on LCM versus what you have in SQL Server?
So the question is, can we synchronize the configuration name that is defined in the LCM, so locally, and what is upstream defined in the pull server? So technically that would be possible by getting, or do a self-invoke, for example, from, hey, give me, based on my agent ID, my node object, and just reapply that in the MetaMoth. But you have to do some work for that. It will never sync itself. And there's use cases, pro and con there, because if you want to do server-side assignment and something goes wrong and you reapply a MetaMoth, there is potential there to override the configuration name locally, where you would pull down the wrong configuration. So having a server-side assignment is a little bit more clean, if you ask me. Any other questions? All right, then I'll wrap up. Thank you.